Hello everyone, and I'm back again with another video. So hi, my name is Antoinette C. Paanoy of PSEC 3A. I'm going to discuss you a certain topic for my performance test number 9 in ECE 23. Moving forward, my learning objective is to demonstrate how arithmetic encoding and decoding works. So first, using my ID as a reference number and letter A as that will represent at the end of the file. So I did arrange everything in order so that will be easier for me to put this one in the probability line later. Wherein considering that A is found as a 1 in probability in 0.1, 7 as well, 0.1 dash 0.1, and 0 is found 0.1, 1 has 2, so that will be 0.2, 2 has 2, that will be 0.2, 9 has 2, that will be 0.2. So next step, since everything should be make sure that it's equal to 1, and that's correct. All of this probability is equal to 1. Moving forward, let's start with the arithmetic encoding. So for the arithmetic encoding, you're going to start provided with a table a while ago, so 9. So 1.0 is the upper boundary and 0.0 is the lower boundary. So adding the 0.2, which is the probability of 9, which is equal to 0.2, and then adding another 0.2 equal to 0.4 for the number 2. For the number 1, adding 0.2 again, which is 0.6 in total. And for the 0-7 and letter A, which are the probability is equal to 0.1, added in every step of the way here until we can get through for the upper probability or upper boundary, which is 1.0 for the value of it. Next step, since the original value is my ID number, so considering 2019-7192A, so starting with number 2, we are just going to expand this and making the 0.4 and 0.2 will be the upper boundary and lower boundary, and then focusing on the 0, which will be the next value to be encoded. So make sure that rescale is equal since the original value will be just divided into 10 bits, so added accurately with the 0.02. So here we matches 0 as the 0.34 and 0.32. So for this value, we're going to expound it again. We got 0.34 for the upper boundary and 0.32 for the lower boundary. And then focusing on the number 1 to be encoded on the next step. So we have the original value divided by the 10 levels. So we are going to add every step of the way 0.002. So we have here 0.328 for the level of 1 and 0.332 for the upper boundary. And then expound it again. We get these values here. Since the original value divided by 10 levels, so we get 0.004 added in every level. So we get 0.3288 for the upper boundary of 9, since that will be the next number to be encoded, and 0.328 for the lower boundary. And then next step, which will be the dash. So for the dash, focusing that we are going to we were able to get the 0.32864, which is the upper boundary, and 0.32856, which is the lower boundary. So we add each level here, 0.000008. So considering that the next number to be encoded is 7, focusing to that, the upper boundary is 0.328632, lower boundary is 0.328624, and then expand it again for us to get another number to be encoded, which is 1 for the original value of my ID number. So we did focus here since the level is added accurately with 0.000008 every step of the way. So we get 0.3286272 for the lower boundary of 1 and 0.328x6288 for the upper boundary of 1. So expound it again, we get the value focusing to the number 9, which will be the next number to be encoded. So we add 0.000016 and every step of the way, where we just divided for this value to 10 levels. And then we add it with equal for upper boundary. And then we get 0.3286272 for the upper boundary and 0.3286272, which is the lower boundary of number 9. Expand it again. We focus for the number 2, which will be the next number to be encoded. And where the added for the original value in every level here is 0.00000032. So you add it on every level. So we got 0.328627264 for the lower boundary of number 2 and 0.328627328, which will be the upper boundary of number 2. And we expound it again, focusing which we are already on the end of our file. So for the end of our file, we have here 0.328627328 for the A, upper boundary, and 0.32862732216 for the lower boundary. So we got the upper boundary here and lower boundary. In order for us to get the binary code for my ID number, we are going to add both upper boundary and lower boundary and then divide it by 2. So we got 0.32862732248. So using a calculator, I did convert this middle bound to a binary. So we got 0.01101000101101010101111101011. And then we are going to convert this back to check to decimal. So we got 0.328627324799999999957. So we got the average bits per symbol. So that will be 60 in total for this binary number. And for the decimal, we got 20 symbols. So we divided both 60 over 20. We got 3 bits per symbol. So moving forward, we are going to do the process of arithmetic decoding. So considering we are going to focus with this value in order to get or to make sure we got the correct value. So since we start with number 2 for the original value of my ID number, which is 2019-7192A. So for number 2, we found this decimal into this decimal, right, on this number 0.2 and 0.4 in the middle of this. So expound this, we get this values. Focusing on the next number of 0, we found this values here 0.34, 0.32, and then expand it again. So we found the values here in the middle 0.332, 0.32, which are the values for 1. We expand it again. Next we got 0.332 and then 0.328, since that is where we can find this decimal for this value. And then we expand it again since we have here 9 for the next number to be decoded. So 0.3288 and then the middle of 0.328. So next, which will be the dash. So that is in the middle of 0.32864, found in here 0.3856. For that will be 7 to be decoded for the next step. So since this number is found in the middle of 0.328632 and 0.32864, we expound it here again. And since we got this value here, we found that these values can be seen at 0.32862888 and in the middle of 0.328672, and then expand it again. Now we can get the number next for the number 9, which will be decoded in the next step, which is the upper boundary of 0.3286275 and 0.3286272, where we found this value here, and we expand it again until we can get the value for the number 2, 0.328627328 and 0.328627264. We expand it again for the next step. And then we got the upper and lower boundary for the letter A, which is the end of the file, which will consider that this decimal that we did calculated a while ago can be found on the middle of 0.328627328 and 0.328627321. And for the summary, again, upper boundary is this one that was mentioned, and lower boundary is this one. And the middle boundary is the binary code for my ID number, which is 0.32862732248. And my ID number is 2019-7192A. So we got it correct. We did check it. We follow the arithmetic encoding decoding process. And that's it for today, guys. I hope you've learned something from me. And thank you, and see you on my next video. Goodbye.